Alright, let me pull up chat before anyone really gets here. What's up, chat? Alright, looks good. Working on finishing math. Alrighty. I don't know if I'm going to do this bonus because okay. So we want to. Are you trying the glove 80? I'm not trying the glove 80. How do you pop out the chat? Pop out. Pop out. You'd think I was Playboy Cardi. Alright, where do I... Okay, that's on 2. Boom. There we go. Got the chat next to the stream. All set up. What's up, Andrew? I guess it's just you and me right now. That's cool. Little one-on-one conversation. Yeah, do you like the Glove 80? I think it's... I got my copy of it right here. Well, this is one half of it. And, like, the build quality is really good, and there's a lot I like about it, but at the same time, like, it's not been enough for me to switch. Like, I'm going to switch, I think, at a certain point, but I need, like, I need a custom layer setup, and, like, there's just so much, like, let's see, I can look up, like, the glorious, oops, Ngrammer. Is that what it's called? Yeah. So this guy, like, made a whole ass thing, and you know me, I'm, like, obsessed with being optimal. And so, like, I feel like I'm not really squeezing the juice out of this shit until I have, like, something that's really, really, like, Homer mod maxed, and all the Homer mod debounce is great. And I've seen, like, someone else, I don't know, somewhere in my GitHub issues, like, dropped an interesting recommendation on... GitHub is so hard to navigate. Dev blogs, maybe. Favorite dev blogs. Oh, that was me who opened it. Yeah, maybe it was this. No, it was the next one. No, it wasn't. It wasn't. Okay, never mind. I don't have it. But basically, someone also. With this was like, you could have a keyboard layout, you know, that's like got all these symbols on it. You know, if you're typing like the implies like arrow, like if you're constantly typing like this, or if you're constantly typing this, or, you know, maybe you're doing some Rust and you're like, and you want your return type like that, you could have that little arrow symbol, and like putting keys on a special layer for that and all that stuff is like such a huge rabbit hole, and like can already type kind of fast, so I don't know. I it's something I'm gonna definitely look at in the future, but yeah, RSI. That's a reasonable reason. Yeah. Refer me, boy. Hey, dumb. Thanks, that's nice. Alright. So, I'm gonna finish this number theory homework. I got two problems. And, I don't know, hopefully get someone... Let's see... I'll post and see if anyone is willing to hop on a call. Doing some math homework. Hopefully some cracked Germans. The Germans are so good at math. They're very efficient people. Color scheme is vague. Oh, what's up, fellow short guy Reens? Reens is an OG. He's been here from like day 3. You were there that summer I rose to fame and became super prominent. Oh, we'll see if we can get Vlad back. Yeah, make some money. Started taking my math notes and types to NVIM from your videos. Thank you. That's very heartwarming to hear. Also the Taiwanese, you know, I heard it's like my friends all invest in like Taiwanese semiconductor factories because like the Taiwanese people are really incentivized to work because they have to like if they're no longer like producing good quality product, we might not like protect them from mainland China anymore. So like they're really, the workers really want to work. The LGTN. Someone said there should be a VPN called the LGTN. I think that's an awesome idea. I kind of want to make a Discord, or not, fuck, I read that, Freudian slip. I kind of want to make like a logo for the LGTN. Yeah, the Discord's real. Is Sideways the new drinking meta? No, I just always have done that. I don't know why. I'm a math, computer science double major technically, but I might have to take like 1 gen ed extra for the computer science major, and I'm not trying to do all that. No, it's just that Taiwan is super sophisticated, developed supply chain for semiconductor production. It's basically no other country has. Oh, okay. Who made the YouTube profile picture? My mom did. Can I be your personal assistant? That's like very interesting, but your grammar is freaking me out. Nope, not Jewish. A lot of people think I'm Jewish. Okay, all right, enough. Enough nonsense. How do we solve this? Because I've got analysis class later, and I want to be able to prepare for that. Types template for math problems is actually just very vanilla. It used to have a template. I used to use this thing called TinySet that I made, but that was like actually butts. I should probably private that. Yeah, it was really bad. I didn't really know what I was doing back then. And now I've kind of reset to just putting like at the top of the file, like I have these 5 statements, and then I just kind of copy them over, and I'm just going to add more as I go, and then maybe make that a template if it becomes enough. And then I have this little thing for dark mode. Okay. All right, back to the problem. So we're proving that if d divides n, then we have 2d minus 1 divides 2n minus 1. This is just like a factorization problem, I think. It's just relying on the fact that, like, I think this is right. So, like, x minus 1, well, you can factor 2 to the x minus 1 into x minus 1, and then plus the series 1 plus x squared plus ... plus x to the n minus 1. And I think using that fact, we can say that where am I? I think using that fact, we can say we could take a factor of, well, x in this case is d and then n. uh, what do you mean I hate how unorganized you are? Because I am pretty unorganized. If you want to be led into this Discord early, write me a compelling email convincing me why. Bust out all your rhetoric and you'll get in. If I see an LLM though, you're perma-banned. Unless you can like use an LLM without me noticing, and then I guess you deserve to get in anyway. Okay, so that's true. Using the expansion for... so we can just do that for, instead of x, do it for n, and then instead of n, do it for m, or what do we have, d? They should be the other order. And then we want to show that since d divides n, well, if we're starting with d divides n, can we then just subtract 1 from both sides? And then show that they have I'm not exactly sure how to go from here. Alright, I need my Greek mod to ban this Diddy Blood guy. Yo, shut TF up, bro. Yeah, I did go to University of Vermont. So if d divides n, n minus 1, I'm not sure exactly how to build up from here with symmetry. It's actually kind of confusing. I want to make sure I'm getting that expansion right too. Of Marines, are you able to you're more of an applied math type guy, I think. What is this AI overview? Garbage. Okay, no, I was right. Yeah, that was correct. So subtract 1 from both sides, then multiply. d times some m is n. We just want to show that 2 to the d minus 1 divides 2 to the n minus 1. That means something times... That means d times some m equals that. So we have to show they have a common factor. And if we can show any of the factors divides any of the other factors, then that's fine. No, they didn't give it to me above. I literally wrote that down, you bozo. I'm gonna have to switch to Emacs eventually. Okay, so we're want to show that that expansion. Want to show. I'm gonna put this all in multi-line math actually. This is a bit awkward. Want to show that d times like some m equals this. And let's join that and throw like an and. Using the fact that d equals like some kind of jn or jd equals n. If we do some kind of substitution, would that help at all? We want to show that. We're not given that. Oh, hello, hello, Russian oligarch. I'm afraid as tempting as that is, I'm gonna have to decline. If n equals d to the k, then you can write 2 to the n. Yeah, welcome to the stream, Vlad. Oh, and we got Alex back. Epstein is worse than who? I'm pretty sure like most politics we hear about is just agitprop at this point, to be honest. It's just so outrageously ridiculous. It's like there's no way this is... I was talking about this actually with the server earlier and we concluded it's just like... Epstein was more intellectual, though. That's crazy. That's crazy. Studied physics at Harvard. Shit. Someone said if d equals nk, then you can write 2 to the n minus 1 is 2 to the d minus 1. Or you can write 2 to the divides as 2 to the nk, 2 to the dk. Oh, that's smart. Yeah. That's a better way to go about this. Okay. Using dk equals m. We say that 2 to the d. I'm actually going to create a variable because this is going to get annoying. Benefit of types. Just because I don't want to have to put parens. So 2 to the dk, get rid of the space, minus 1 equals 2 to the n minus 1. And then we could using the expansion, probably put a period there. Using the expansion, and would using the expansion help particularly? I mean, yeah, it probably will. You've got to. Whenever you see 2 to the d minus 1, you know. So we would have on one side 1 minus dk times 1 plus dk squared plus dot plus dk and minus 1, and then that would be equal to, what would that be equal to? Same thing, but with d. Wait, no. I'm getting so variable confused. dk equals m. No, dk equals n. What am I saying? Equals 2 to the n minus 1. And we want to show that that divides d, or d divides unironically, Epstein came up with the word too big. Now this is number theory. Let's see. Thinking about this hard. So if dk equals n, oh, Okay, so then we sub that in for, that means we want to show, if this was just D, we'd want it to divide. So we'd want to show that divides that, like that. And so I think I'm expanding wrong. I think by expanding, I'll write on paper. I think by expanding dk, I should not be doing that. I should be treating it as like d to the k, because then I'll get a more reasonable I think we can write 2 as d to the k also as, 2 times d to the k, and that is the sum of the geometric series 1 plus 2 to the d plus 2 to the d squared with q equals 2d. I love how this guy was like spamming Epstein stuff and then he goes to actually solving math. Some people are just built different. What kind of MacBook do you have? Won't you have problems with some classes like operating systems class, hardware synthesis, or VHDL? Verilog don't work well on Macs. Haven't run into any problems yet. I don't know. Macs are like really there's basically tool chains that work for most things. I haven't run into Verilog problems, but how do I make my camera look like what? It's just my laptop camera. I'm in front of a window. Okay. So you're saying we can do 2 to the d to the k minus 1. And technically we're looking at this being x. So what we get for the expansion of that, oh, I'm sorry, Ambit. You can have the credit. It's got lens flares and stuff. Oh yeah. I think it's just it's really bright out. I also don't want this brand to get any free press, so I hate this shit. Why did I even drink that? I think 2 times d times 2 times k would result in adding the exponents, but I could be wrong. I think you have to exponentiate to get them to multiply. Oh yeah, straight up the Epstein guy did rip you off. Mbit 0393. Two to the d. And that's the sum of the geometric series 1 plus 2 to the d plus 2d squared with q equals 2 to the d. Yeah, I'm just confused on how the geometric series like fits into um you're a high school student? Yeah, I would start early. I mean, yeah, you were screaming Epstein over and over again. Look at the form EULA for the sum. You will see what I mean. We're supposed to know that. It's just the geometric. Actually, no, I'm not going to open up a chat bot in case I said something heinous. What? Oh, for the geometric series. Or one plus q plus q squared plus n minus 1. Arithmetic series. Yeah, that's familiar. Ah, yeah. Yes, yep. Yeah. Yep. Does make sense. Alright, so expansion of this is 2 to the d. 2d. 2. Wait. 2 to the d. To the d squared. K minus 1. I think it's like that. Parentheses might be messed up. Yeah, they're fucked. One, 2 to the d, 2 to the d plus 2 to the d squared plus It's I'm studying math and computer science. Well, search. Sure, I mean, yeah, I could. I mean, it doesn't make sense because you're booting up Node either way. Like, who really gives a fuck, you know? Yeah, Vlad is a real one. If you're gonna talk to a chatbot, you have to boot up 600 billion gigs of JavaScript anyway. So, I just prefer not to. Fucking hell. So that expansion, can we use the fact that n equals dk? Yeah, I'm not focusing. This is an interesting question too. Just to move on for a sec, like how 2 to the 35 minus 1 is divisible? Like, how would you know that? Is this another... verify. Verify. No, problem with chatbots is you don't learn anything. I'm trying to build my mathematical intuition. I haven't tried lean yet though, but I'm gonna go into lean definitely. I'm just trying to focus on my classes right now. It's tough when you have like a hyper focus around all different kinds of subjects, but brother, follow me here. You want to show that the fraction 2 to the dk minus 1 divides 2 to the d minus 1 is a whole number, right? Either notice that this fraction is exactly the formula for the geometric series I mentioned earlier. Okay, yeah. So we don't even have to expand, actually, is what you're saying. I'll comment this just in case it's needed, but... So we want to show, well, two to the dk minus 1, I can just say dk. Over 2 to the d minus 1 missed that. Maybe we don't even need the expansion. I see. Where... I see. And we can just say that's really a brilliant move. The problem with math is like, well, at least for me right now, I'm just gonna keep practicing it. But like, a lot of the stuff kind of asking people to help me on stream, you might argue is like, why is that better than asking a chatbot to do it for you? You know, because that's not really my solution necessarily, but It's just gonna take a lot of time, and like to be honest, like I just forgot the the geometric series expansion, but the factorization of this I didn't know before I started streaming math homework. So I'm just hoping like over time it'll just build up more and more intuition. You're right, the lens flares are pretty sick. How did I get that to happen? It's like a specific point. There we go. Yeah. Alrighty. So, which is the and the geometric series 1 plus, okay. 1 plus 2 to the d and we know that that's a whole number. Whole number n. Oh, rigorize this shit. This is gonna be fire. It's a whole number n, therefore n times 2, well, I'm gonna copy this because I don't want to retype it. I'm lazy AF. Therefore, equals n implies n times um, 2 to the d minus 1 equals 2 to the n minus 1 implies, well, what we're looking for, 2 to the d minus 1 happens to divide 2 to the n minus 1. Qued. Oh. That seems like you always type the problem. So that 2 to the d squared is also 2 to the 2d, not 2 times 2d like you wrote, but the rest is good, man. By the way, mortality gonna copy. Yep. He's just a high school kid though, man. Like you were probably tweaking out when you were at that age too. I remember I was very weird in high school. It took me a while to become normal. Am I single? Yeah, I am single currently. 2 to the d squared is 2 to the 2d. Not 2. Oh, I see what you're saying. I see what you're saying. Yep, in that line. Yes, yes, you're right. So some parens are in order just to be extra careful. We're talking like that. Yeah. Choose a different letter for whole number. Oh, you're right. You're right. You're right. You're right. You're right. V. 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 Good man. Yeah. Good call. Good call for sure. God damn, it's bright. I'm moving the shade. Alright, that's a bit better. Now we just got one slice of light right in my eyes and like the complete darkness in the background. Alright. Yeah, it's a little goofy. I want to see if I can get fast, like as fast as I am on paper, just by typing. But then, like, I'm worried I'll show up to an exam and I'll be like, where are my macros? Verify that that monstrosity is divisible by 31 and 127. Anyone have any hints on this? Oh, I lost my chat connection. Oh, there we go. Back. Your focus on pseudo-intelligence is distracting from your life. Hit the gym, get jacked, and go carnivore. Interesting. Euler-Totient function. Write these numbers as 2 to the x minus 1 for some x and use what you just proved with me earlier. Okay, use binomial. All right. Yeah. Okay. Reasonable. So well, as 2 to the x minus 1 for some x and then use what you just proved with me earlier. That's smart. Holy shit, is this Ambit guy? Oh my god. Oh my god. Well, I mean, and Kane said the same thing. Kane. Oh my god. Nothing teaches you math like benching 225. Sure doesn't. That's just so funny. Dude, I go to the gym, but it's like they're just showing up and being like, stop doing this pseudo-intellectual shit and work out. Why do you need brain when you can be strong? That is really smart. Oh my god. So we can write 31 equals as 2 to the 5 minus 1, right? result, 2 to the 5 minus 1 divides 2 to the 35. Minus 1, oops, minus 1 since 5 divides 35. Boom, beautiful. And then we can write 127, sorry, is what they want. I should have recognized this as powers of 2, which is 7. Yeah, it's gotta be 7. And using the previous result, 2 to the 7 since 7 divides 35. Boom. That was cool. Don't take my solution seriously, bro. I'm on something right now. What are you on? Guys, after school, I think I'm gonna move to Silicon Valley and do a bunch of mescaline and stuff, and crazy hippie drugs. What good is your math and programming skill unless you're happy, healthy, and rich? What good is anything unless you're happy, healthy, and rich? Might as well just give up. This is number theory. Okay, should we try to do the bonus? You guys have gen ed classes you just don't give a fuck about? I have this linguistics class right now that's absolutely killing me. Not because it's hard, it's just because it's like, oh. Bonus. Put this in bold. Bonus. Oh, the 22 should be in bold too. The nth triangular number. So triangular number is just it can be represented as this sum. It's like the sum of the first n integers. For what values of n does t to the n divide the sum, or t sub n divide the sum that's weird. Let t sub n denote the nth triangular number. For what values of n does t divide the sum? So what they're asking kind of is like, and let me just minimize this. I'm going to use paper for a second. I know. Don't freak out. I'm talking to myself. Jesus, it's bright. All right. So what they're asking, I guess I can move this a bit, is why is this like still right in my eyes? Oh my god. My eye is twitching. So t sub n is the nth triangular number, which could be expressed as n times n plus 1 over 2, which is just the summation formula. And they're asking for what values of n does this divide the sum of t to the n So like the sum of the sum, I guess, is kind of weird. Like, for what values of n does the summation of n divide the summation of the summation of n? Take examples and try to solve it from there. Okay, that's a good idea. Good strategy, good strategy. All right, so let's see for 1. So for 1, the value is just 1. And does that divide 1? It does divide 1. Cool. Then 2, we're going to get 3. I should write 1, 2, 3, 4, 5, 6 or something. And then we're going to get 1 plus 3. So that does not divide. Then we're going to get 3, which is going to be 3 times 4, 12, 6. And we're going to get 1 plus 3 plus 6 equals 10. Does not work. 4, well, we're going to just add, we're going to get to 10. 1 plus 3 plus 6 plus 10 is going to give us 20. That does work. And then 5 is going to give us 15. Am I correct in that? We're just adding 15, 21. Is that correct? 6 times 7, 42, 21. Yep. Divided by 35. Nope. 56. Nope. Okay. Weird. All right, write a Python script. Okay. Not a bad idea at all. Let me go back to this being big. So I in range 1,000. Oops. What's floor division? That. Okay. Is that correct? Python 3 provider. What? That's annoying. Okay, that's not. Division by 0. Oh, mod. No, what am I talking about? I just want to get a feel for, actually, that's not a good way to do it. I just want to print this out. So let's just do I and then the sum and then sum of sum. Okay. And so that's what we verified by hand. Does 15 divide 35? No. Did I lose my chat connectivity? Oh no, live chat. Denote the nth. For what values does it divide the sum? I actually do kind of just want to write this out. So T sub n would have to divide each of the terms. Or a divisor of T sub n would have to divide each of the terms. T sub 2. The nth triangular number is 1/2. Yep. Oh, what's up, Quelo? Good to see you here. I don't know, man. The math shotties are they're hard to find. Plus t to the n. Wouldn't this itself be like t to the n times t to the n plus 1 over 2? Whoa, someone dropped some crazy inline LaTeX. finite. Okay, so the sum divides man, this is hard to read. So the sum divides a double sum. So n times n plus 1 over 2 divides the... So, okay. So n times n plus 1 over 2 divides n squared over 2 plus n over 2. So n times n plus 1 over 2 divides m times m plus 1 times 2m plus 1 over 12 plus m over 4. So it's hard for me to like parse all this LaTeX in my head. If you could give me like a more verbal hint, that would be helpful. Let's see if anyone... I was writing out the sums of t of n explicitly and simplifying. Sum of t of n. Let me move myself so I'm not blocking. Oops, how do you select? There we go. Zoom in a bit. And that's the sum of basically t to the n, which equals the sum of over 2. And then I should be worrying about indexing, but I'm just not for now. Then we could say, using the summation formula, basically, we have k plug in this whole thing. I don't want to type it out. So it would be like, oh, it's messed up. What did I do wrong? That. Plug. So we're plugging this into the summation formula. So it would be that plus itself, well, that times plug plus 1 over 2. Is that what you're saying? You get a factor of t sub n plus front out front. You get a factor of t of n out front. I don't know if they give you all the factors. This is just t to the n. Then using the n times n plus 1. Oh. Expand the sum series. Okay. I mean, or this is just the same as t to the n. T to the n squared plus t to the n over 2. And the well, I know the formula for n squared, it's just n times n plus 1, 2n plus 1 over 6. So but are you saying substitute that in here for n squared or t sub n squared? Oh, can't you just factor out n times n plus... Yeah, factor and then split. Equals k squared plus over 2 plus k over 2. So you can make use of that. So, I mean, what we could say is like... Oops. What the fuck? Where'd that a come from? So we could say something like... like that. Just want this to align nicely. Well, I'm going to snap it all back to the start so I can work on it. And we could use the summation formula. Oh. I do trust Quelo. Go back to the equation with the sigma. Equality you wrote isn't true because k is a variable. So you're saying that should be n? And not k? Quality you wrote isn't true because k is a variable. Oh, the one where you substitute Tn in the place of k. You want me to leave this expansion? Like that. That one's correct, just remove the rest of the line. Just this massive equation, you mean? Oh, yeah, what am I doing with that? Right, because that's... Thanks, guys. Okay. And the formula for sigma squared is n times n plus 1 over 6 and that's a little weird. And then this would just become like that. Quelo and Trial are really carrying here. Hello, 5A6NN. So we could factor out a k and a k plus 1. And then we'd get a 1/12 of a 2k plus 1 plus a 1/4 could factor out a 1/2 as well. Probably be interesting. Could actually factor out a 1/4, but I don't really feel like that. Should be n, not k. The k's are used in the sum only. The k by n after summation. Oh, you're right, you're right. Boom, Vim. See, you can't do that on paper. Man, I love Vim with a burning, fiery passion, more than I'll probably ever feel for a human. All right. Now, this is the expansion of this. And we're wondering for what values of n does t to the n divide? So what values of n? Now add what's in the bracket. Okay. So you're saying something like, if we want to move this inside, it would become, we'd have to multiply it by 6, so we get 3. So this would be 4. And then factor a 2 out of that. So it would be 1/3 n plus 2. And what does this exactly tell us? You missed a 2. Did I? Have to remove the 2 in the denominator. You mean in the first part of the fraction? Oh, am I double counting? Divide by n and see what happens. I mean, divide by n and see what happens. For what values of n does t of n divide the sum? Well, you just get rid of that 1n. It would just be n plus 1 over 2 times n plus 2 over 3. Yeah, just to visually simplify this, probably better to say. Probably even combine this further. Oh, that pushed it off the page. Never mind. But we could multiply the bottom together. we could say this is a 6. Right? Divided by n is n plus 1 times n plus 2 over 6. I'm still not exactly sure how that gives you values that this... Now the sum Tn is something and you want it to be divisible by Tn. So you need that something to be an integer. Now divide this by n. What if you divide it by Tn so the result would be a whole number? That's interesting. Dividing. This goes on to a whole extra page. Fuck. Dividing by Tn, which is n times n plus 1. Over 2, correct. We would get, we basically get what's inside here, which I kind of simplified down a bit too much, but I think you just get n plus 2 over 3. Mod 3 n equals 2. I meant int cause some. Is that guaranteed to be a whole number? T plus 2 needs to be an integer. No, divide by n instead of Tn. Why divide by Tn, or why divide by n instead of Tn? Yes, you proved it yesterday. The product, of 3 consecutive integers is divisible by 3. Yeah. For what values of n does T of n divide the sum? That's your answer. So when to, DZJ Johnny. You have an expression for t of n. We would get when this is an integer all right. And that's valid. That's sufficient. You're all good, trial. How long did this take? I don't know. The stream yesterday was 4 hours. The stream today was... How long has the stream been going? I guess it is a little bit dishonest to get a bunch of math nerds helping me out live, but they said you could work together with people. Like 6 hours. All right, cool. Stoner Local. Fun name. Better than asking a clanker. That's so funny. That's such a funny robot slur because they're not even embodied yet. Okay, cool. All right, I'm gonna check what other. See if I have other homework. I thought I had an extra tab, Firefox. There we go. Okay. And here's the compilation speed if you're curious. Done. Boom. That was quick. Okay. Let's see if I have other assignments in analysis. Assignments. When is this due? Due February 14th. Okay, so I have a bit of time actually before this is due, but might as well get started on it early. But there was actually... There was a question that I wanted to look at if people are interested. I'll try to pull this up. Actually, I want to try something too before we go to do. Did I say your homework is a Valentine's letter? Writing straight types at maths makes it so easy to make mistakes in writing, in my opinion. You might be right, yeah. Yeah, you're actually probably right. It's probably better to typeset after the fact. Yeah, probably way better. Let me bring this to the front real quick. let's see, is this readable? I don't know if I can fix this on screen in a good way. So showing that the iterated series of, we've got an I and a J, and then the absolute value of ij converges, and then you can kind of ignore that parenthetical phrase. I usually ignore when they provide extra information on math questions because it just confuses me. Then the iterated series without the absolute value also converges. So like intuitively that makes sense, right? Because it's the same series, it's just not bounded by the absolute value. Like you have now, it's just going to be less than the positive value, less than or equal to the positive value, and greater than or equal to the negative value. So you have like an upper and lower bound. So it's like, it makes sense it's convergent, but to make this rigorous is like kind of confusing to me. Yeah, real analysis jump scare. Just failed real analysis. Any tips? Man, I'm gonna fail real analysis if someone doesn't help me with this question. I shouldn't be giving you advice. Yeah, we were chilling with number theory, but can I share the PDF of my homework, you mean? What's the chat message limit? Can I override that? What I could do is just copy this file and put it in my dot files. Maybe I should just start doing all my homework in my dot files. Just have like a mono repo of everything. Okay, yeah, that's kind of a fucking dumb idea, but I'm gonna do it. So what's the best way to do this? I'm just gonna delete this entire number theory thing and the real analysis thing and just go go hidden. No, how do you see hidden? Toggle hidden files and directories. Oh, you can't when you have unsaved changes. Okay, now we're talking. Okay, so delete those. Config. Homework. Uh-oh. Did we lose them? Oil's confusing sometimes. Uh-oh. Did I lose my homework on the permanent? I'm gonna be very sad if that was the case. Well, I have this file. I have the temporary buffer. Real danger of that. Okay, well, that's fine. Good thing we have Vim's internal backup. I literally always do that with oil. Yeah, someone said the triangle inequality. Yeah, we'll get to solving this in a second, but for now, okay. So I'm just gonna analysis, number theory. Okay. Oh, these should be directories. So I lost my homework archives. Whatever. We don't worry about it. All right. And that still should render just fine. Yep. All right. Now I'm fine because I have like my personal journal and stuff in that notes directory. I don't really want to commit it. But this I'm fine with committing. Okay. I don't really want to right, I'll throw my... Oh, use arrow keys in insert mode? That's a great question. I actually have a whole video about that, but no, there are a couple better ways to move around when you're in insert mode. Like you can use, you can do that. Some people have binds set up so you can like do option and move things around. For me, that's screen resizing though. But some people like that. There's also like Control O, which lets you one-shot move. You see when I do Control O, there's like that. So then I could go to the top and then I'm still in insert. That's a little weird. To be honest though, I mostly just do escape. And then there are a few things like in math mode when I'm typing like, I have a snippet for that and then I have Control E to jump out. Same thing for a variable. I think I have V and then name and then E to jump to the next thing and then A plus B, and then I can jump to the next thing. So it's kind of nice. Think you show absolute convergence of the sum. When will there be a shrinking stream, Boom Boy? I want to be 5'6" That's awesome. I'm glad I'm bringing people back to the light of being a little guy. Did everyone get this question? I'm gonna minimize this again. Yeah. Think you can show absolute convergence of the sum. How does organization and notes and types compare to something like Markdown or org mode? Well, that's a great question. I would say strictly types is like a superset of Markdown. It has all the same syntax. I haven't tried org mode, but types is like more on the finished, finalized document than like plain text representation. Thanks, yeah. We have the math PhD or math master's student. Not to overqualify. Jumping on in a sec to help out with this question. Gender capturing, linking navigation, all max. Oh, sweet. Hello?
Hello.
Yo, how's it going?
I'm good, man. How are you?
Great. How many people are watching right now? I can't really see.
64 it says for me.
Man, that's crazy. You would not think like doing random math would be that entertaining.
Well, I mean, I guess it is. I'm here after all.
Yeah.
Could you show this question again? It's a bit hard to see.
Yes, I can. It's basically
Do
like
we
we're.
want to show?
Yeah, go ahead.
Uh, we have to. Okay, I'm just gonna write it down for myself in the meantime. Just
All right,
makes it a lot easier.
cool. Feel free, anyone else who wants, write this down too. What's given convergence of the double iterated absolute value series, can we get convergence of the same thing without the absolute value?
I think what people were saying with what people were saying with like triangle inequality, this makes sense. I think this also is what absolute convergence
Hmm.
comes down to.
Okay. Yeah. What? Can you give me like what is the definition of a triangle inequality?
So the triangle inequality says, I mean, you can state it in different terms of generality, but just as, let's say, in the real numbers or the complex numbers, that the absolute value of a sum is always less than or equal to the sum of the absolute value.
Absolute value of the sum is less than or equal to. Okay. Okay. Is always less than or equal to the sum. So like that, you mean?
Yes, Steam is always a few seconds behind. That's exactly what you're writing. Yeah,
Yeah. Okay.
exactly.
All right, cool. And the reason like
Because so my idea, I have no clue if it's actually going to work, but my idea was that um, like uh, we have to show that we first have to show that all these like inner sums, so like 6 and I range over the J converges. This follows by like absolute convergence. Um, and then we have to show that once we have all of those, that that's like summing over all the I still converges.
right. So we have to show both pieces.
Kind of, yeah. The first piece I think this is immediate. So if you kind of use their notation, like from the exercise, if you call this bi this sum over these absolute values, then because the sum of the absolute value converges, then just the sum over the aij's itself converges. So maybe you can like introduce like another notation if you call like ci the sum over j of aij. So for a fixed I.
So this converges to bi, and you're saying like the sum of bi. What's the other base? Oh, I equals 1. Like this would go to ci.
Yeah, exactly. So there's like this criterion which says that if the um, if the sum of the absolute values converges, then the sum also converges. So this is kind of what we're implicitly using here. Because VI is well defined, CI is well defined.
Right. I see. Yeah. Some real number.
So, and they're given to us that the sum over all the BI converges, and we have to show now that the sum over all the CI also converges.
Yes.
So my idea was that if we can show that the sum over the absolute value of the CI converges, then again, this is sufficient to conclude that the sum over all the CI converges.
Okay.
So, and I hope this will work out. So you wanna?
So the sum of the absolute value of
So the sum of the absolute values over all the CI I hope that this is going to converge. And I think what you want to do is, I think what you can do is like, before we take the limit, let's say the sum runs from I equals, what is it, like 0 or 1 to some number n.
Right.
This absolute sum of absolute values over Ci. I think you can say that the absolute value of Ci should be less than or equal to Bi. And I think this is where this triangle inequality comes into play.
Okay. And so we're trying to take the limit of the sum of Bi.
We're trying to take the limit, or my strategy is to take the limit over the sum over the absolute values of the Ci. And if we have shown that this limit exists, then we may also conclude that the limit of the sum over just the Ci exists, and that is what we want to show.
Okay. Oh, okay. Yeah.
So my idea was, so we consider this sum, and I want to show that this, like for the sixth n, this thing is going to be bounded by the sum from I equals 1 to n of Bi. So there's going to be bounded above by that thing. I mean, this is a claim. I think you still have to prove this properly.
Right.
But this is what's going to happen. And this thing on the right, like these are both, because this Bi is a sum of absolute values, each of these Bi is going to be non-negative. Therefore, this sum from I to n of these Bi is like increasing as you let n increase. But we know it converges. That's, well, basically saying this sum over these Bi is bounded above. And therefore, the sum over these absolute values over these Ci's will be bounded above, and it's also increasing, and therefore it also converges.
Okay, yeah.
This will be the strategy of proof.
Yeah.
It's a bit convoluted.
Right. I guess I'm also kind of shaky on the definition of convergence. It's just
Fair enough. Yeah, this may be a good question. Like, what, I don't know, what have you covered in your analysis class so far? Because I am implicitly using here, well, not implicitly, but I'm using here that if you have a sequence which is increasing, or let's say non-decreasing, and bounded above, then it converges.
Right. Non-decreasing and bounded above.
Yeah, so it will always come, because if it's bounded above, it will always have the set of all the elements in the sequence will have a supremum, and the sum will always converge to that supreme. I guess the sequence. Yeah.
Right. I see. Yeah. And it has to be increasing or at least non-decreasing, because otherwise we would need a lower bound.
Exactly. Or otherwise it could like oscillate, and then it would not.
Oh, true. Yeah.
It would just. Exactly. You can do the opposite, where it's like non-increasing and bounded from below, and then converges to the infinite. But yeah, I don't know if you have like covered already like this theorem in your class.
Yeah, I mean we have. I just like haven't had to apply it yet, so it's like it keeps falling out of my mind.
It's a very useful. Yeah, fair enough. It's a very useful one in real analysis. So, okay, so let's think to do this. The gap in the proof for now was to say that this sum, let's say from I equals 1 to n of the absolute values of the Ci, that this is actually less than or equal to the sum from 1 to n of just the Bi.
Okay, yeah.
Because that's what we want to show, and that should be fine, I think, because it would be now sufficient to show that if we show for every I that absolute value Ci is less than or equal to Bi, well then if we add like smaller things all the time. Like, yeah, in the sum. I mean, technically you can prove this by induction if you want, but I mean, it's pretty clear.
Wait, I'm not entirely sure why it's clear because
I mean, so suppose we have shown, right? We haven't yet, but suppose we have shown that the absolute value of Ci is less than or equal to Bi for every I individually.
yeah, okay.
Then this, for every n, like this sum over the absolute values of Ci better be less than or equal to the sum over the Bi. Because
Okay.
like
Yeah.
in like if you increase n, right? Every time you add something to the left hand side and to the right hand side, but every time what you add on the right hand side will be greater or less,
Right.
or at least as good.
And why are we allowed to suppose that?
I mean, we haven't. I'm kind of like breaking the problem down. So now we've kind of reduced it to more or less to showing that for every I, the absolute value of Ci is less than or equal to Bi.
Right. Oops.
I mean, this is not yet done,
Right.
but this is like how I think about the problem. I'm like pretty sure this will work out, but I'm not 100% going with
Yeah.
this one.
Yeah. Okay. All right. And do we have?
Because now, sorry, yeah.
Yeah. Yeah. Go ahead.
So I think now we can look at the definition. So the absolute value of Ci, if we just plug in what Ci is, it's the sum over the J of the Aij. And this Bi is just the sum over the Aij. And now maybe you can kind of see why I said that the triangle inequality looks quite promising, maybe.
You're saying so the double sum of
There's no double sum yet. It's just I plug in the definitions of Ci and Bi into this inequality that we want to show.
Ci and Bi. Okay. And Ci is just it's just this sum of Bi and Bi. Is that correct? This is just the definition of Ci.
Yeah, the stream is a few seconds behind, but wait, I gave you, I think. Wait, I think we have a different definition of the Ci. Yeah. Okay, I think I told you wrong. No, by Ci I mean the sum over J of Aij.
The sum over
Sorry.
J. Oh.
Exactly. Otherwise, yeah. Otherwise, it would be weird. So it's like it's kind of similar to the Bi, but there's no absolute values inside the sum.
Oh, okay. So I was summing the whole Bi. So we're showing that for J Aij is less than or equal to their Bi. Which is
Exactly, and you want
absolute value.
the whole thing on the left in absolute values.
The whole thing?
I feel like or I guess I'm trying to think. I think we could we skip the absolute values on the left? I'm trying to. I think it. Oh no! I think it might make it easier because we want to use our absolute convergence criterion in the end. So I think we might want the absolute value. Yeah, exactly. So this thing at the bottom is what we want to show, right? And we know that each of these sums like actually exists and like make sense. So now this is like in big quotation marks, apply the triangle inequality infinitely many times, kind of.
Oh, I see. Like a generalization of the triangle inequality.
Yeah,
Wow,
yeah.
yeah.
So this thing is probably maybe like a theorem or something you have in your class, because yeah, you can show this. This will be true. Like if these sums both converge, then this inequality will be true.
Wow, that's genius.
Yeah, it's like the triangle inequality. It's very versatile. There's like an analog also for integrals, which are kind of like very, very general sums. It works very similarly.
Yeah. Yeah.
But okay, so let's suppose we have shown this thing on the bottom, or we suppose we know this very last thing. And then what is the actual argument? So we know for every I, this inequality at the bottom holds. That is, for every I, the absolute value of Ci is less than or equal to Bi. Therefore, the sum from I equals 1 to n of the absolute value of Ci is less than or equal to the sum of I equals 1 to n of just Bi. This latter thing is bounded above, and both these sums are non-decreasing. So, well, the left thing is also bounded above. Therefore, the sum of the absolute values of the Ci converges. So this thing converges. That means that the sum of the Ci converges absolutely. So the sum of the Ci converges, and that's what you want to show.
Yeah, and I don't actually have to like super formalize this because this isn't like an assignment or anything. It was just a random exercise. But we can say that the sum of Ci is bounded above by just like an arbitrary element in Bi.
I mean, you were going to show that the sum of the absolute values of the Ci is bounded above by another sequence, namely that of the Bi, the sum over the Bi, and that thing is bounded above because the limit converges over the Bi. That's like one of the assumptions that converges.
Right.
Therefore, like this. Yeah, exactly. So we can also conclude that the sum of the absolute value of the Ci is bounded above, and because it's non-decreasing, this thing must actually converge.
I see. Yeah. Yeah. Well, the triangle inequality is kind of like just key to this then.
Yeah. The triangle inequality is like real analysis 101.
Gotcha. Yeah.
Very important.
Yeah.
I mean, yeah, it also works for vectors. It's quite I think, like, because you can, like, for real numbers, it's, like, not that much saying, right? It's, like, you can do, like, cases depending on whether, like, x and y and their sum is positive and negative and just see what happens with the absolute value.
Right.
But if you just think of, like, vectors, then, like, if you think of the sum of two vectors, this is kind of like putting these two vectors, like, head to tail. So it's kind of, so you can, like, if you think right about this, like, geometrically adding two vectors, this kind of forms a triangle. You have the two vectors that you want to add, and then the actual addition. This kind of forms like a triangle.
Right.
You know what I mean? And like the longest side of this triangle is gonna be the length of the sum of the vectors, and the sum of the other two sides is gonna be the sum of the absolute value of the vectors. So what this kind of is saying that the straight line to a point is the shortest distance.
Whoa, yeah, you're right. Yeah.
Yeah, and it's also where this name triangle inequality comes from. So it's a natural thing.
Wow. Yeah, that makes a lot of sense. Yeah. Yeah. Hmm. I guess so you must have gone through analysis like a while ago at this point.
Yeah, I went like let's see, like 5 years ago by this point. This is very long ago.
Yeah. But it seems like you still remember all the definitions really well. Do they come up in the work that you do?
I mean, real analysis much less, but like this triangle inequality is like this idea is very like fundamental, right? Because yeah, it's this. It comes up in like lots of context, and it's this. Yeah, it's like one of these things that you will remember. Like there's lots of things in real analysis I've absolutely no remembrance of, but just like these few key things is what me in this case helped me like put it together. Like we have this absolute convergence, it's really nice. The triangle equality is really nice, and like if a non-decreasing sequence has an upper limit and an upper bound, it converges. Like it's these like three facts, right?
Right.
That kind of like makes it all come together. So I just remember like a few facts because they've come up like afterwards. I think also like in multivariable real analysis and these kind of courses. But yeah, there's a lot that I've got.
Yeah. Yeah. Um, I'm also curious, like, do you have any kind of experience with like lean and like the intersection of computerized proofs?
Unfortunately, I don't. I think it's very interesting.
Yeah.
I haven't yet. I've seen people do it. Actually at my math department, there's now like quite a few people who are very, very interested and actually do research and do this kind of stuff.
Yeah.
But I haven't yet. I think, yeah, it sounds very, very cool, very promising.
Yeah, it does. It seems like just really cool for I know some people like using it to verify like their programs and stuff. It seems like something I should learn later down the line because it's like just between math and programming.
Yeah, I mean,
but it's like fuck
I've
thing.
Yeah, fair enough. I feel like I mean I have no clue, but I think this idea also existed longer in the computer science world, right? Like verifying your program like formally.
Yes.
Isn't that where it kind of came from? I'm not sure.
Yeah, it did. But have you heard there's like that? I forget the correspondence, like the Howard Curry maybe. That's like programs and proofs are there's a bijection.
Yeah, the Howard Curry, something along those lines. I know what you mean. Yeah. That's
Yeah.
very cool. And yeah, the other side is the category theory, which is great.
Yes. Yeah. Yeah, I know about that from that channel Oliver Lug, but that's about my exposure.
Fair enough. There's another channel. It's called Simplification of G, and he's very much on the intersection of like math and computer science. Maybe you would like it.
What's it
very
called?
Like mini videos. Some are very. Yeah, the sheafification of G. It's a math term. I can type it in chat.
Oh yeah. That would be sick.
Because he does like, I really like his math stuff. It's like it's funny and full of memes. It's very categorically often, but I like that. And but he also has like computer science stuff because I think he quit academia, and he works as a software engineer, some like pretty hardcore stuff. I have no understanding.
Ooh, that's a pretty cool guy to know about then.
He had because I think you mentioned yesterday, right? This channel like K-Theory. This K-Theory often does like interviews with people, and he like I think just a few days ago or a week ago he did actually an interview with this other guy.
Oh, that would be very cool. Yeah. Yeah, there are some really, really talented people out there. It's kind of I don't know, this I love knowledge work. This is like really cool, but you do have to go up against some people that are really, really devoted.
Yeah, that's very true. That's very true. It's quite competitive out there.
Yeah. Yeah. But I don't know. That's the nature of it, I guess. Like it's just I used to worry about that more, but like math is so huge, I guess, that like there's a good chance you just won't end up competing with people too because there's so much to do.
I mean, this is it. I think it depends how you take it. Because yes, you're very right. Math is very huge, and you can, and I very much agree that you can always like find a niche that hasn't been explored, and that's even like quite interesting if you know where to look. But
Yeah.
like, it's a different question of like still being able to do it professionally. Because at least here where I am, like funding is not free, and it's very, very, very competitive actually to get like PhD positions and postdoc positions. It's getting like quite ridiculous.
I see. Yeah. Yeah. Do you know like what you want to do long term? Do you want to become a professor?
I mean, that kind of would be a dream, right? But I'm a bit realistic about it. Like for now, I'm like applying to PhDs, but I applied now to like let's say five, six, or something.
Yeah.
I've had like one rejection, two interviews where I haven't heard back, and some where I don't expect to hear back. You know,
Yeah.
it's like it's very tough out there. But because I mean, because these like are positions, just like most of the time in Europe, where right they have like some project description in mind, and they're actually hiring people who have like already like specialized in this in their
I
master.
see.
So they're
Yeah.
looking for certain kind of people, and it's like, you know, it's fully funded. It's like an actual job. You get decent pay. So a lot of people really like this. So you have like per position, you have like over 100 people who are all like actually good at math and kind of are in this direction,
Yeah.
and then only one gets hired. So that's it's quite tough.
Man, yeah, that's so stressful.
Yeah.
I hope that doesn't undermine the
So,
enjoyment of it.
no, I mean for now, yeah, I like doing my master thesis. Yeah, this it takes up a lot of time. These PhD applications, and this, like at this point, I'm more time like just doing these applications and doing interviews and stuff than actually working on my thesis, which is like slightly problematic, I would say.
That
But
is really problematic. Yeah, that should be kind of there should be someone who's like going and looking out for you, not the other way around.
yeah, exactly. I mean, my supervisor, she helps me and stuff. And I should say, in the US, I feel like it's much better organized because we have like this website by the American Mathematical Society. And like in the US, it's like super well organized. Like every math position, like academia on all levels, is like on that website, and you can filter and you can search. But like
Mm,
for Europe, like there's no equivalent. It's truly like survival of the fittest. Like some universities will only post like in their own local portal, like their job. Others will go to some random obscure website and post it there. But they all use a different obscure website, and you have no overview of them all. And they have like terrible filtering search systems. And
yeah.
yeah, it's kind of terrible.
Hey, there's a business idea right there, though. Just get someone to consolidate them all into a nice browser UI.
That that would be so. I know a lot of people would be very happy to even pay for
Hmm.
that.
That's interesting. If anyone hears that and needs a project to work on, if you can do some web dev, that's
Yeah, that would be really nice.
yeah. There's no
Yeah, more
shortage of
than now
problems.
that's true. I just have like this long list of websites in a file somewhere that I'll like have to manually go through and check and see if anything new has come up.
Oh no. Yeah. There's so many things like that actually, like just all over. I'm quite excited for like the Claude stuff coming out. Like give that a few more years. Just having like a bot do all that work for you, like that stuff kills me. Like applying to things and just the bad old
Yeah,
websites. It's like that's not what I want to do with my life.
true. Yeah, it's yeah. I mean, yeah. I guess there's some advantages to AI and stuff. Ah, very true.
Yeah.
But yeah, to your question earlier about what I want to do, I mean, I would love to. I mean, I think there's a realistic chance I get a PhD,
Hmm.
and then afterwards, I don't know. It just gets, in some sense, like it gets less competitive, right? Because there's less people who have gone into a PhD who want to continue.
Yeah.
But then like those people who have finished their PhD, those are like real machines.
Right.
So it gets really tough, I think.
Yeah. Yeah. What's your like area of interest again?
I mean, so it's I would broadly say algebra, but like things like number theory and algebra, geometry and algebra, these kinds of things. So
Yeah.
I mean, to be more precise, I would say arithmetic geometry, but I don't know how much this means to people in general or to you.
Hmm. Yeah. Arithmetic geometry. That is very cool. Yeah.
Yeah, it's yeah, I think it's very cool. It's one of the more technical areas. It's which sometimes I really hate myself for choosing this and like why couldn't I do something more straightforward?
Yeah.
But on the other times, yeah, it can be very cool.
Wow. Yeah. I guess Wikipedia is not the best source on.
In general, math Wikipedias are not the worst, but sometimes they can be very short. That's just way too short. I
Yeah.
mean, what it's about, I can like the quick sales pitch, right? Okay, so algebraic geometry studies solutions to polynomial equations, right? If you have like an equation, say x squared plus y squared equals to 1, if you think of like the points x comma y which satisfy this equation, they form like a unit circle in the plane,
Yeah.
right? And so it's about these kinds of objects, and the point is like you can use the algebra of the underlying equations to study the geometry of the shape and vice versa. And there's this very, very general and rich interplay between them, which is like, yeah, people have put like way, way too much time and effort to this. Like the rabbit hole goes unbelievably deep, and yeah, I think it's quite cool. Yeah, no, like truly, like some of these things, it just you learn something in math or like some course, and you think like this is crazy abstract, and then the next course like completely blows it out of the water, and it just keeps going like that forever. It's crazy.
That's so cool though, and like I don't know. I think it's really cool that this stuff. There's probably stuff out there in math that like we've already discovered, but it's just like so abstract that we haven't found a use for it. But like as our computers become better and we like become better at representing the world, like I bet a bunch of that stuff will become just like super valuable.
Yeah. I mean, yeah, it's also like I think like maybe I don't know about you, but people on the outside often have this idea. I feel like that math is kind of like this stagnant thing. It's kind of like been done, and
Yeah.
mathematicians, they just calculate bigger numbers, bigger integrals. But like there's regularly like going like big revolutions on in fields, kind of like even like whole like paradigm shifts and stuff like this. Like people are actually like discovering things or inventing new things, however you want to frame it. And
Yeah.
it's very exciting stuff going.
Yeah. Yeah. It's actually like I'm just feeling that about all kind of I don't know academia. Like I felt like we had stagnated as a species, but now that I'm like considering grad school and stuff, it's like wow, we actually are getting pretty far. There's a lot of stuff to discover.
There's so much stuff. It's yeah, that's the best thing. Like there's always like in math, or at least it's one of the best things for me. It's like always so much more than you could have ever imagined is true, and like everything works out so beautifully, and it's great.
Yeah, it is truly amazing. Um, so yeah, I if you want to tackle a couple other problems, I have this analysis homework that was it's not due for like a week and a half, so I might not know some of the definitions they're trying to get here, but I don't know. I think it's stretching your abilities is good.
Yeah. I mean, I think this one, to be honest, this one looks, at least the first one, a lot easier than the previous one. Like
Hmm.
this last one we did, this wasn't, I wouldn't say it was an easy problem. I was kind of lucky that I saw what was going on, I think.
Hmm. Yeah.
So, just the sequence, if they phrase it like this, okay, so wait for n. Um,
I guess this is they want two different.
I think they just want. I think they like if they phrase it like this. I feel like they want you to use the definition of. I think maybe like epsilon delta or something.
Of convergence. Yeah, I'm not sure I know that very intuitively off the top of my head yet, but
Fair enough. Or
well, I probably should.
okay.
I think it would be a good thing to.
I mean, knowing off the top of your head is one thing. Like being, like I wouldn't say you need to know it off the top of your head. What's the important thing is like you know like the vibes, right? You know like what's the picture I have to have in my head, and from that picture I can recreate the definition if I really need to.
Yeah, that makes sense. Okay.
But for this one, I feel like at least for part we can kind of tease it. I feel like we can get away with some. Like right, that's what math in the end all about. You want to find some clever strategy and avoid doing something. So then I feel like in this case where this absolute value is less than 1. Well, let's first, like, if x were positive and the absolute value were less than 1, then the sequence is actually strictly decreasing, right? Because you always multiply by the same number, which is less than 1. So you always multiply by, you always make it smaller in each step. And it will actually be bounded below from 0. So it will converge to its infimum and be 0. So this is like, but here I kind of have used that x is positive. Like, because if you have like, let's say x is negative, but its absolute value is like less than 1, then it will like, if you go through the sequence, it will flip from like negative, positive, negative, positive. It will slowly always like get to 0. Yeah. So maybe you can just choose that. Yeah, that one.
Okay.
So I feel like the definition is probably the way to go, and I feel like if they write it like this, that's also kind of what they want you to do.
Yeah. I guess. Let's see if I can. I thought I had this real. Damn, there's tons of random TypeScript gibberish. Okay, I guess I just have to check my normal mathematical analysis. There we go.
Also, the like using the epsilon delta definition is not going to be a very, very difficult here. Like not very complicated. I think this will be like easiest.
For convergence, you mean?
Yeah, to show like both to show the convergence and divergence directly from the definition.
Let's see. This is a really weird PDF. I don't know why it's like this.
Which book are you using for it? Apostle. Okay, I've heard of this. I don't know it, but I've heard of this.
Yeah. I have like an Italian teacher, which is interesting.
Wow. Cool. But is it true that you guys always like have to buy textbooks and stuff, and they're like super expensive?
Yeah, it's the worst.
That's great. Because for me, at least where I am, it's like common that the courses get taught every year. So this guy just writes lecture notes, like exactly like for this course, it's going to be the same every year.
Yeah.
And they just put it online, and you get to use those lecture notes, or you can print them for like $5 or something, whatever.
Yeah.
It's fun.
It's weird. Like we kind of have the same thing. Like the professors will post their lecture notes, but they also require you to get a textbook, and it's so annoying. Like I can pirate all of the textbooks. Hopefully that doesn't get me in trouble to say, but like I never pay for them. It's really annoying though.
Yeah. I mean, I guess when I say lecture notes, so far, I mean they do like at the beginning, it's a bit shit for the professors. Like the first time they have to teach the course, they have to put in a bit more work because they kind of write it like a book, but like a book specifically designed for that course, right? Like exactly those topics.
Right.
And then all the later years they just reuse that. So I mean, yeah, it is kind of like if you have to teach like a lot, which I think you have to do more in general in the US. Like, I mean, I don't know if this is like 100% true, but I feel like they're like positions often involve more teaching, so maybe you won't have as much time
Yeah.
to do all these kind of.
I think that seems worse to me. Like the lecture, having like one professor lecture to you isn't honestly that helpful. I feel like you should be spending most of the time solving problems and like just going to the professor one on one. But I don't know. Like
Yeah.
sometimes
How is it with your class? Sorry, what would you want to say?
I like will show up to my math class lectures and like I'll just like not learn that much, I feel like. And if like just doing math homework for longer is like usually better.
Yeah, no, I agree. How is it? Because at least in undergrad for me, it was like there was for every course it was like you have first 1.5 hours of say like traditional lecture, but then there's a 1.5 hours exercise session where you just do problems there and there are people to help you with the problems and stuff. So you spend as much time doing that, or there's like as much time reserved for that as the actual lecture. Is it kind of similar
No,
for
it's
you?
not similar at all. You're completely on your own to practice.
Ah,
Yeah.
that's tough. That's it. Yeah, I can imagine. Yeah.
Yeah. Yeah, I don't know how people without like a social media following handle this.
Yeah. Yeah, I
Um,
mean, yeah, it really helps to have like this community. Like in your case, let's say social media, but or in my case, like being there in the classroom with other people and like TAs, and you get on the one hand you get help, and the other, and you also get like incentivized to actually do something and try something and spend time on it. Which, as you said,
yeah.
that's the most important.
Yeah, absolutely. Because it feels like if you don't have that, it's very difficult to do. Because you just like have to spend so much time on your own, and it's like not the social element is big.
That's true. Yeah, no, I truly like math. It it's very important to do it together. Like people have sometimes a kind of the stereotype, right? Oh, math, you just spend hours alone and in your head. But like talking about math, talking about ideas is like so important. Like at all levels. Like at just learning things, at teaching people things, and then later doing research, talking to other people. It's yeah, very important.
Yeah, totally. I think like also heavily with programming as well, and it's just it should be done more than it is, more than I see it at my school at least, but it probably gets better at grad level.
Yeah, yeah. Maybe. I mean, yeah. It depends. At least for me, it was that you get together with like let's say more like-minded people, have more like social interests with you. That's nice.
Right. Um, what am I even looking for here? The definition of
Definition of like a limit, just the for the real numbers, it's like epsilon delta definition, the upper bound. I think it's probably a bit further than here because we're still defining the real number. Completeness actually all these terrible things.
what functions in inverses, set theory. What? I should really look through the
So maybe can you go to the index again? Yeah. Let's see. I think not chapter 1. Let's see. Chapter 2, some basic notions of set theory. I also don't think so. Damn, sorry, what is this book? Chapter 3 going
I know.
point set topology before you do analysis? Kind of crazy stuff.
This
Okay.
is this book is really weird, yeah.
Yeah, hardcore. chapter 4 is where convergent sequences in a metric space. I think that's what we want.
All right.
I don't know if you've talked about it in that much generality. Like, I don't know if they've talked about what a metric space is, but it won't be much different than the special case we're interested in.
What is a metric space?
Also, the definition is already in 4.1, this introduction. But a metric space is so it formalizes this notion that you have a notion of distance, right? Let's say on the real number,
Yeah.
you have two real numbers, and you can talk about like the distance, like intuitively on the number line, it's just the absolute value of their difference.
Yeah.
So you can kind of think of it this as like a function, which takes in two real numbers, x and y, and it spits out the absolute value of their distance, of their difference. Sorry, and you can think of this as the so-called distance function, or a metric better.
Yeah.
And so, like in general, what a metric space is, it's a set together with the data of such a function, and this function satisfies like a few axioms. One of this, which is basically the triangle inequality, and again, it captures this thing like a straight line should be the shortest path, something along these lines.
I see.
And
I see.
a few other, like one of the, I don't know them all. It's like three axioms, but one is say like the distance between 2 points is 0 exactly if those 2 points are equal. Like these kind of very obvious things, but it gives you like a powerful tool, because as soon as you have metric spaces, you can do analysis. Although there's like a asterisk that normally you want complete metric spaces, which are a bit nicer, but I don't know if you talked about completeness in your class at all.
Not yet. Dude, that's so fucking cool. You can just like import a bunch of functionality once you know one thing. Math is so awesome.
Yeah, this is what it's all about, right? Because like it's great. Exactly. And then because then I don't know, you probably haven't you haven't seen topology yet if you're doing the analysis.
Yeah.
Topology like generalizes this in a crazy way. It's very cool. But we have this right on the like the beginning of like 4.1. We have already the definition, which is for us interesting. Like, what does it mean for a sequence of real numbers to converge? It says this limit converges for every epsilon greater than 0. There exists a capital N such that this difference xn minus our limiting value, or potentially our limiting value, is less than epsilon for all small n bigger than capital N.
Okay. Yeah.
So, I mean, do you get the intuition behind this thing? Like, why this is a reasonable definition?
No, I don't think I do. I think there's too many variables for me to.
This is, I think, it's like a notoriously like hard one to parse.
Yeah.
And like, there's a lot of quantifiers.
Yeah.
But so the thing is, so we have like we fixed some number epsilon greater than 0, which is like our error margin. You can kind of think of.
Okay.
And we have to say there has to exist some integer value n, so some point in our theory, such that whenever we look beyond that point, like this small n bigger than capital N, our series xn has to be really close to capital A, our limiting value. Or like it always has to be within this error margin epsilon, right? You can kind of see again like this distance function that's going back, the absolute value of the difference.
Gotcha. Okay. Yeah.
I mean, it takes a while to get used to, but this is like this. So for every error, it's kind of like a game. Like, how do you prove that the limit exists? Like, I'll give you some error margin, epsilon, and it's your job to find some cutoff point such that when you're past that point, your sequence will be close enough to your limiting point within the error margin.
Okay. All right. That's starting to make a bit more sense. Yeah. I can see that. Okay.
Exactly.
So to show, like, back to the problem, that um, to show that this converges, we have to come up with, well, are we given the error margin by that less than 1, or do we have to come up with that stuff ourselves?
So it's you have to, for every error margin, you have to come up with a capital N. So the capital N is
Oh,
gonna generally depend on the error margin. Like, so if you give me an error margin of 1, let's say, then I can probably choose like a pretty small capital N. But if you
right.
want an error margin of 0.001, then I'm probably gonna choose like a big N. So
Right.
we have to like find in general. So you start always like let epsilon greater than 0 be given or something like this. You always start like given some arbitrary epsilon, and then I have to cook up a capital N and show that the condition is fulfilled for that capital N.
What did you say in the second? Let epsilon greater than 0.
I said be given, yeah, sounds fancy, like, or just let epsilon greater than 0 is also fine.
Okay.
It's like this, it's kind of like a meme. It's like these real analysis proofs always start with let epsilon greater than 0. Everyone always uses like epsilon for this error. Very
Yeah. Yeah. Gotcha. Okay. And then we want to produce some capital N such that we have that inequality where, um, like x sub n
It's
minus
useful
a.
to
Oh, is less than.
less than epsilon.
Less than
Yeah, at the
epsilon.
beginning,
Okay.
it's a lot of switching back and forth from the definition. That's, yeah,
Yeah,
harder.
this well, let me throw this on the same. Oh, oops. Okay. Didn't mean to show my internal view. There we go. Man, my window manager is really tweaking out. Okay. Yeah, it's confusing to me, just like the raw amount of variables we're dealing with, I guess. Like
Yeah,
we've got
yeah, that's
a
why I
little
said
n,
like, yeah,
big N, epsilon. Yeah.
yeah. Like this thing, like also don't like I can't tell you like I mean maybe at this point like after so many years I kind of know it by heart, but like yeah the key point is like it's so many quantifiers you really have to like get a solid grasp on this intuition by practicing, and at some point you can just like come up with the correct definition from like it should be exactly this and this is how I formalize it.
Right. Yeah, yeah. I see. I see. So we got all right, where's back to the problem. All right. And we want to show this is less than the error margin. Well, that's what we're trying to show, but this, oh shoot, there's so many different like disparate pieces of information here, you know, like there's the textbook, there's the homework, there's also the, I guess I could combine two of them by writing the
I
problems
get it.
down, but that's annoying.
Exactly. Yeah, I guess they call it. Well, we can just fill in what our this a sub n is, like, or in your case x sub n. It's just x to the power n,
Right.
right? So you want this x to the power n minus a is smaller than epsilon, and you want this for all small n, or you want to find some capital N such that this holds for all small n beyond that capital N.
Okay, so we want a capital N such that this holds for all n smaller than it,
Bigger than it.
bigger than it. Oh, bigger than it. Yeah. Okay, yeah. For all n greater than. Yeah. So this for all n greater than an arbitrary cutoff point.
Exactly. And we in our job to come up with this cutoff point based on epsilon.
Okay.
And also what we have to come up with is this capital A, because that's like the limiting value. Like, because like what this shows you is like if you have proven this, then you have shown, well, not only that the limit converges, but that it converges to that exact value, A.
Right. I see. So how do you go about this? There's a couple of like free variables you need to.
Yeah. So I think here the first thing is like we know, right, what capital A should be. As in we know intuitively what this converges to. So you kind of have to know like what should it converge to, and then I can actually prove that it converges to that value.
Right, and work backwards, kind of.
Yeah, we're very much gonna work backwards with these proofs. It's like as always, like what we're gonna do in the end, we're gonna look at this inequality and we're gonna see, okay, like what does this imply, and kind of work all the way backwards, and then it will kind of pop out what our value for capital M should be.
I see. Yeah.
So, but in our case, our capital A is just going to be 0, right? Because
Right.
we can see like this value is just going to converge to 0. So we're just going to worry about the absolute value of x to the power n. And we want to show that this is less than epsilon.
Okay. For all n greater than. So we can now pick this big N such that this inequality will be true.
Exactly. We have to exactly at this point we have to pick this big N. And yeah, this big N can definitely depend on epsilon.
Right. Okay. And we could kind of rearrange a little bit. To get, I guess if we're trying to solve for n, what would always be less than epsilon? Like, could we take the log of both sides?
I mean, kind of, yeah, but first we want to, you can bring out the exponent n outside the absolute value, because the absolute value is the second multiplication.
Oh, yeah. That's smart, yeah.
Exactly, and then, I mean, if we're like, I don't know how your real analysis class is kind of set up, but sometimes, like, when they're like really pedantic, they like define the real numbers very carefully, like in your book, and they like, what does a logarithm even mean, blah blah blah. Because yeah, you do want to take a logarithm, but
Right.
I mean, I think it's fine here, right? Everything is positive. Logarithm is an increasing function, so
Oops. Yeah, I'm gonna get rid of those for now. I'll like actually properly typeset this later, but okay. Oh, actually, this would be like n times. And this is kind of just scratch work, right? Because we're just gonna go back and substitute the answer of this in for an n.
exactly. So yeah, that's basically always how these proof goes. You first do this a lot of scratch work, and kind of how you write down the proof is just your scratch work backwards. Yeah.
Right. And then, so we could say that n is like less than ln epsilon, kind of over absolute value. Well, would that work for an n? Because
I mean, it almost works. At this point, you have to be slightly careful because now we would get that this n would be bounded above. So it's kind of a sanity check that kind of something went wrong here. So we want this small n, it's going to be like bigger than something in the end to make this inequality true. But the point is that the absolute value of x was strictly smaller than 1. So the logarithm of the absolute value of x, if you like think about just the graph of log or something, it's going to be negative. So we have this inequality and we divide by something negative, so the sign inequality gets flipped.
Yeah. I see. Wow, that's, gotta be careful with that.
Yeah.
Yeah.
Exactly. And I mean, if you want, you can also like replace this right-hand side by the log base x of epsilon. It's the same thing. It doesn't really matter.
Oh, wow. Yeah. Oh, I see. Yeah. Log properties, yeah.
Exactly. It does. Yeah, it doesn't really matter because now we have kind of, I mean, we are with this case almost done, right? Because now because all our like steps here are by implication. Like we can say like if small n is bigger than log base x, or I should say log base absolute value x of epsilon, then the line above, then the line above, then the line above. So we get our equality. And that's what we want. So if we just take our capital N to be literally any integer that's bigger than this log base absolute value x of epsilon, then it will work.
And just to verify that, if you were to plug that in, then the logs would...
Okay, in your logs, you do have the base of your log has to be the absolute value of x. The base of a log always has to be positive.
Oh, right. Yeah. Yep. Gotcha. Yeah. And so if you plug that into x to the n, then you just get an epsilon is always less than...
Exactly. You can read your sketchwork kind of backwards, right? So now you say, I've chosen my capital N, and now kind of, or how you would like technically write it down is like you say, I choose my capital N to be this random value. Then I say, let small n be bigger or equal to capital N, and then you go backwards through your inequalities, and you get that the absolute value of x to the n is less than epsilon.
Right. Yes. Yeah, I see. Yeah. And you'd choose n to be like a greater than or equal to this arbitrary value, and then plugging in, you would get... I guess I'm a little confused by the sign here. You would get the log would cancel with the exponent, and you'd get epsilon minus 0 is less than or equal to epsilon.
Wait, something epsilon minus 0 in absolute values? Something weird.
Yeah, I just thinking like, oh, actually, yeah, it doesn't really make sense to plug that in and verify it algebraically, because it's something greater. It's like a different inequality.
Yeah, I mean, I think this is fine, right? So, I mean, if you, I don't know how strict they are for you with like handing in work and how neat your proofs have to be. But this is more or less it, right?
Right. Yeah. And how would this differ if we had that absolute value of x is greater than 1?
Exactly. So because now, yeah, this is where the real fun begins. Now it's not going to be that much different, but the sequence will not converge, right? That's just what diverges means. It's just not converges. So if you want a definition of diverges, you have to look at your definition of converges and just negate it. And it's going to be a hell of a lot of quantifiers. So yeah, it's going to be a bit awkward. So maybe it helps to write out like what does it mean to show that the sequence diverges if x is strictly bigger than 1, or bigger than equal.
Yeah, I guess showing that it's, well, you're negating all of the terms of the definition of converges.
Yeah, because like the converges, it's like this long string of quantifiers. For all epsilon greater than 0, there exists capital N such that for all small n. So you can negate this and then you'll see what the definition is.
Okay, yeah.
It's a bit awkward. I mean, you can also just, if you kind of like get to this point where you kind of know what the definition should mean, then you can also just vibe it out.
Right, yeah.
So let's see. What do we want to show? It does not converge. So I guess first of all, we want to show that there does not exist a limit, right? So that there does not exist a value a real number a, such that, and then sum for all epsilon. There exists an epsilon, so there exists this error margin epsilon for which the criterion fails.
Right.
That is, there exists an epsilon such that whatever capital N you choose, the inequality will not hold.
Or could you say the opposite inequality is true? Like flip the
Exactly. Yeah, exactly. Yeah.
Yeah. Yeah. Okay. That makes sense. So, oh man, there's just that thing has so many variables.
Yeah. So we want to show something for all capital A. Like what we're showing is that for every possible real number, it cannot possibly be the limit of the sequence.
Oh, that's a good way of looking at it. Yeah.
So for all A, okay, it's not a limit. That means there exists some error margin epsilon. That is, there exists some epsilon bigger than 0, and then such that something. So for all A bigger than 0, there exists epsilon bigger than 0, such that for all capital N, whatever capital N you choose, there exists a small n. Such that for all A exists epsilon.
I guess I can break this up. This will render like horribly. I just like I'm writing it out kind of. For all A greater than equal, there's an epsilon greater than or equal to 0, or greater than 0. Such that for all n, there exists an n.
There exists a small n such that the opposite inequality works.
Right, such that less than 0, or okay, which is x sub n minus a.
Exactly. And then there's a few very small things, namely a doesn't have to be bigger than 0. A can be whatever. We want to show it for every limiting value.
Oh,
And this n, the small n has to be bigger or equal to capital N.
I see. Yeah. Okay. Yeah.
Okay, so that was what we wanted to show. How many were 1, 2, 3, 4, 4 quantifiers deep? That's that's tough.
Yeah. Yeah, that is tough. That's
Exactly. So, but again, yeah, it's this we have to keep in mind, like the picture. So we're gonna like parse it like a computer would, right? We're gonna say we have to show a for all statement for our capital A. So we pick some arbitrary A,
right.
and then we have to pick some epsilon, and we can kind of think about like this epsilon is this error margin, and we're gonna show that we will fall outside the error margin.
Yeah.
So to make our life easy, we're gonna choose an easy error margin. Like probably the smaller, the easier. But it's not gonna really matter. I'm gonna say, just choose epsilon bigger. Just choose epsilon equal to 1. I think it's gonna be fine.
Okay. And then we have an arbitrary n. Well, for all.
So we have an arbitrary capital N, and again we have to cook up the small n. So we're again gonna work backwards.
Right. I see. So we get to the most inner part, yeah, and then we have to work backwards. Okay. And we have actually, just to replace this, probably x to the n. Or I have x sub n, but it's just x to the n in our case.
Yeah.
But how do we do this here? Because a is gonna not. We don't know what.
Exactly, but we know this time what epsilon is because we've just chosen it to be 1. So we can replace it in the inequality. We can replace epsilon with 1.
Gotcha. But
exactly. So we want to find, right? And I mean, why is this intuitively going to be true? Like as a sanity check, right? This x now is like an absolute value bigger than 1. So if you keep multiplying this with itself, like this x to the power n, it's going to go like arbitrarily big. And this a, this is some fixed value. So at some point, it's going to surpass this a and keep getting much bigger. So we will definitely find some pretty big value of n, where it's like much further than 1 unit beyond a. And then we're good.
yeah, that makes sense, I guess. But it's like for all a, isn't there like an arbitrarily large a in there that could just destroy any amount of.
I mean, yeah, but it's always we fix the a first, and then we get to choose the small n. So a is always going to be some number, and this x to the n is always going to be at some point, always going to be larger than that number.
And we can just say that when we're selecting that n. For all
Yeah, we can let our small n depend on capital N and on a. I don't know if we need to.
Yeah.
We don't even we don't even need to let it depend on capital N.
It could just be 2a or something.
Yeah. So again, and now we have this inequality, and we want to again express n in terms of a, because we want to let our small n depend on a. So let's just like try to manipulate it until we get like small n bigger or equal to something.
We could add a to both sides. and then take the log. But are we gonna have to?
But here you have to be careful though. Like this, as you've written it down, the first step is not. You have to be careful because the a is inside the absolute value.
Oh, you're right.
Like,
You're right. Yeah.
So the easiest way here, I would say, is there's another one, the reverse triangle inequality,
Oh.
which is, yeah, it basically follows from the triangle inequality.
Yeah.
But it's just like it's when you have a minus. So you can say that x to the n minus a, all in absolute value, is bigger or equal to absolute value x to the n minus absolute value of a.
Is greater than or equal to. Like that?
Exactly, and now we can just work with that, because remember that in the end we want to go backwards. So if we show that this thing on the right is bigger or equal to 1, then we will have shown that the whole thing in absolute value is bigger or equal to 1.
Right, because of the absolute, or because of greater than or equal to. Yeah.
Exactly.
Yeah.
So now we want to show that this thing is less than or equal to 1, and now you can bring the absolute value of a to the other side with adding.
Gotcha. Yeah. So then we've just got 1 plus. Yeah. Tricky. Is that?
So you flipped the absolute, the inequality sign. Where did you flip the sign?
I just got confused with the algebra. I was rearranging it, but this is yeah.
Yeah, this works. It's nice. And now we can bring the n outside. We can do our little log thing. It's kind of a similar thing now.
So we've got a log base x of this whole thing. Of n. Well, of absolute value x.
Exactly.
And then this just becomes n. Or is it absolute value n?
No, n is already like we're in a sequence. This n is like the indices of a sequence, which we already assume to be like negative.
Right, right. And like you said, you could technically say like we're doing that.
Yeah, exactly. That's kind of took a second, but yeah, that's the in between step implicitly.
Yeah.
Exactly. So now like the statement reads, right? This also works. Like every step works backwards. So you say like if I choose my n bigger than this random value, or at least this random value, then I'll get the inequality above. And therefore, like, yeah, that's what we wanted to show, right? We went through this whole like what do you call it, quantifier thing.
Right, I see. Yeah, that is a little weird that you kind of start with what you want and then show that you can isolate.
Yeah,
yeah.
Very useful thing. Yeah.
Yeah. Yeah. Yeah. Very cool. All right, I do have to get to class pretty soon, but this has been so sick for building my understanding.
Yeah, of course. What time is it for you now?
It's 2 p.m. or I guess 14.
Okay, I understand.
Yeah, I'm East Coast. Yeah.
For me, it's time to make dinner now, or it has been time for a while to make dinner. But
yeah. Cool. Great stream, everyone, and thanks for the help.
Yeah, of course. Anytime. It's always fun.
Yeah.